Hey Muhammad, what are you reading?
Oh, hi David. I'm just reading this article about air pollution in Hong Kong. It says here that the air in Hong Kong is 20 times higher than the top-ranking city, Whitehorse in Canada.
Really? I have read a few articles myself about how bad the air quality is in Hong Kong. You know, air pollution is a growing environmental problem that has attracted the interest of scientists today. And one of a very serious consequence of air pollution is acid rain.
Acid rain? You mean acid is falling from the sky? Oh no! It sounds as if singing in the rain doesn't sound like a good idea anymore.
Not like that exactly. It's not actually just acid is falling from the sky. Well, here, let me explain it to you in a little bit more detail.
Acid rain is a general term used to describe what scientists call acidic deposition. This occurs when strong acid-forming substances created by the combustion of fossil fuels are transferred from the atmosphere to the earth. Wet deposition, the typical acid rain, is when acid-producing chemicals such as nitrogen oxide and sulfur dioxide combine with water droplets in the atmosphere and fall as precipitation. Dry acidic deposition is when these chemicals reach the Earth's surface via particles in vapor in the air. Nitrogen oxide and sulfur oxides are the two most common contributors to acid deposition and are both found in the atmosphere naturally in low concentrations. To create nitric acid, the nitrogen oxide in the atmosphere is oxidized by molecular oxygen to create nitrogen dioxide and is then combined with water droplets to yield nitric acid. Sulfuric and sulfurous acid make up close to 75% of wet acidic deposition. Sulfur dioxide is combined with water to yield sulfurous acid. Sulfur trioxide, also abundant, combines with water to yield sulfuric acid, which is a much stronger
So all I have
acid.
to do is mix sulfur dioxide with water to create acid rain?
Pretty much.
That sounds simple. Let's go recreate acid rain in the lab.
Think we could do that?
Yes, I think we could. Let's go try it out. Do our experiment right now.
Hey, aren't you forgetting something?
Oh yes, you're right. Pass me my lab coat. Pass me my goggles. Pass me my gloves. Let's go. Oh wait, why don't you join me as well?
Thought you would never ask. Come on.
What materials do we need, David?
Well, we're going to need 15 grams of sulfur, 30% hydrogen peroxide, potassium iodide, calcium carbonate, or also known as marble chips, 100 milliliters of distilled water, 1 Bunsen burner, 1 ring stand and 1 ring clamp, 2 250 milliliter Erlenmeyer flasks, and 1 150 milliliter flask, 1 scale and weighing paper, 1 lighter, 2 strips of rubber tubing, a 2-hole stopper, and a 1-hole stopper, and 3 pieces of glass tubing, 1 pH probe, and 1 vernier interface, and 1 computer, with the computer stand.
We are weighing out 15 grams of sulfur.
To collect the pH of the distilled water, place the probe so the end is submerged into the water. Wait until the reading on the computer stabilizes.
So what's happening here, David?
Well, here, Mo, you see, this is the basic lab setup, and here we have the first 250 milliliter flask. This is containing hydrogen peroxide at the moment, which is H2O2. And you see coming through this glass tube right here, and through the rubber tubing, the red rubber tubing, it goes into the second 250 milliliter flask. This here contains sulfur, the 15 grams measured out in the beginning of the procedure. And coming out of this 2-hole stopper is the second rubber tubing, the orange here, and this goes in and the end is submerged into H2O, or also known as water. And in this lab, you're going to be seeing 3 reactions take place. One is mainly for the production of oxygen. The other is the reaction of oxygen and that sulfur you see here in this flask. And the third is going to be that sulfur dioxide with the water. So what are those chemical equations? Could you tell me?
So, as you can see from these 2 glasses, one has potassium iodide and the other one has hydrogen peroxide. Once we mix potassium iodide with the hydrogen peroxide, pure oxygen, will be released into the container containing the sulfur. The chemical equation is 2H2O2 aqueous will be broken down to 2H2O liquid plus O2 gas. The gas will react with the sulfur inside, creating sulfur dioxide. The chemical equation is sulfur plus O2 gas will equal to SO2 gas. Then, when the SO2 gas reacts with the H2O in the other flask, it will create H2SO3, which is also known as sulfurous acid. In some cases, sulfur dioxide, SO2, oxidizes to sulfur trioxide, SO3. Then, sulfur trioxide, SO3, combines with water, making sulfuric acid, H2SO4.
Sounds like fun, Mo. This looks like a good lab.
I'm singing in the rain, just singing in the rain.
Potassium iodide.
Look at that sulfur just bubbling.
Alright, so I'm going to add some of the into here. Let's take off a little bit of the heat.
Look how quickly that is just reacting. My God. That was unexpected.
Although we ended in a loud bang, we're still going to test the solution that we created. See if it created any sulfurous and sulfuric acid. We'll mix, dislodge any air bubbles.
Wow.
How's it looking?
Look at that pH. It has gone down considerably. What do these pictures all have in common? They have been affected by acid rain. Acid rain, which can be dry or wet deposition, can do this, and it can cause many more other problems such as human health, soil, trees, species, and buildings. But what specifically does acid rain do? The acid simply aid to the deterioration of buildings, statues, cars, and so much more. Repetitive doses of acidic deposition can cause paint to shed off and make an item such as a car look old and worn out. An equation here shows the effects of acid rain on stone, such as graves. CaCO3 solid plus sulfuric acid will equal to calcium sulfate plus carbon dioxide and water. Here, the acid rain is having a double replacement with calcium carbonate, which then has a reaction that flakes off the stone and the inscription on the graves. Often spots where the paint has fallen off is due to acid rain. The worst part, however, is not the effect of acid rain on man-made structures, but on life. Acid rain causes the acidification of lakes and rivers, thus resulting in the water being too acidic for animals to live in. This results in loss of life in these areas, which can also lead to the extinction of certain species and consequently affecting the food web. Recent statistics state that the pH of many lakes in the U.S. are much lower than the normal pH in healthy lakes, which is around a pH of 6.5. This water is absorbed by plants and can lead to the destruction of forests. The total effect of acidic deposition is not entirely known. With the increase of countries burning fossil fuels, the worst of consequences may be still yet to come.
I'm singing in the rain,